Okay, welcome back. This demo is called the Mirage, and it uses a set of two concave mirrors. It's a very cool demo. We have a concave mirror on this side, right here, on the top side, concave mirror. And we have a concave mirror on the bottom surface, concave mirror. Okay, and you put an object here, and it creates a mirage that the object is actually up here. Mirage. Okay, so how is this being done? Well, let's kind of put it vertical so I can show you the physics of this, right? So I kind of measured the distances between these two mirrors, and I found that they're about 8 centimeters. So you put this object like this, like that, and you put this other mirror like this, and the distance is about 8 centimeters. In order for this trick to work, if the distance between the two mirrors is 8 centimeters, the focal point of both mirrors also has to be 8 centimeters. In physics, the focal point is the point where if you have a mirror, let's say a concave mirror, and let's say this is the focal point, right? Focal point. It's the point where straight beams of light, right, will come bounce, and they will always go towards the focal point. Okay, so the mirror has to be in the shape of a parabola so that it can have one focal point, and then any straight beam of light will go through the focal point. So in other words, they will focus on the focal point, and I've talked about this before in my videos called parabolic mirrors. This is why telescopes are made with a parabolic shape, right? And then they can focus all the information on that single focal point, right? It's also true, the reverse is also true. If you have an object at the focal point, right? Imagine if you have an object at the focal point, it could be any object, right? And the light rays emanating from that object, right? Which way will they bounce? They will bounce back straight. Okay? This is the opposite of this. This one is saying all light rays that go straight will bounce through the focal point. This one says all light rays emanating from the focal point will bounce straight. If you've ever gone to the Science Center, the California Science Center, there's actually a demo that shows this. There's a demo that shows this. There is two dishes, right? There's two dishes there. This is at the California Science Center, the IMAX, right? And then they have seats there, right, facing the opposite direction, I believe. And then people sit there, right? And the two dishes are in the shape of a parabola, and you're supposed to be sitting opposite so that you don't actually see each other's mouths moving. And you're supposed to speak into the dishes. And the whole idea of that is that they're trying to show you exactly this phenomenon. So as this person speaks, the sound waves will go, right, bounce off the dish. And which way will they go? They will go straight. Why? Because they're sitting exactly at the focal point of the dish, right? So then the sound waves will go straight, right? They will go straight, and then they will go right into the ear of that person because he's also sitting at the focal point. So they will go right into their ear, right? Like this, and then like that, like this, and then like that, right? And of course, the same thing will happen. They will speak, and then they will go like this, and then it will go straight, and then they will go into the focal point. So they will be able to actually hear each other, even though in the midst of that clutter, there's a lot of other people in the museum. They should be able to hear each other if they are carefully listening to each other. So this illustrates this concept. So what's going to happen is this object is sitting at the focal point of this mirror, so the light rays will go like this. So this is the focal point, right? The light rays will go and they will bounce back straight. They will bounce back straight, right? And then the focal point of this mirror is also over here, you see? So this is the focal point of the left mirror, and then the focal point of this mirror is also over here, focal point here. So then the rays that bounce like this, they will start at this object, they will go like this, they will bounce back straight, they will come back at the focal point of the other lens, of the right lens, like that. And so this object will form an image here, and that's called a real image. Why? Because the rays are actually crossing and they will form a real image. This is real image. Real images have the tendency of making it look like the object is actually there, right? So people will come here, and the trick to do with this experiment is to close the lid like this, to close this, and people actually do not see the object that is sitting on the bottom. So you can put any object that you want. People don't, you should have the people looking from the side so that they don't actually see the original object. And then this object will form an image like right here, and that's a real image. A real image, and then people will try to grab that. So I'm going to show you. The first object I could use is a little piglet like this, and then you put it on the mirror here. Okay, so I'll show you how the demonstration works. So you can see here that this is a concave mirror, right? Like this, the curvature. And then you could put an object like this. And then this is another mirror, same curvature, right? This is another mirror. And then you tilt it over, people don't see the mirror. It's just black, right? So then you put this object here, you cover it up. And then this is the original object, but you don't want people to see that. So then you go from the side, and then people come and try to grab that. You see, it forms an image here. And it fools the cameras, it fools the videos, and it's forming a real image here. You want to try to grab it, and people go, where is it? Where is it? You see? And it's not there because the original object is sitting down here. You see here? This is the real image. This is the original object. And it's forming a real image here, which you try to grab and you can't. But if you view from the side, the real object is hidden. You see? So it's a really cool trick. You could put anything. I could put even the cap of the marker. You see? Then you try to grab that. You see? So right there. And then the real cap is underneath that. So you can kind of make any kind of mirage effect there. Put different kinds of objects, try fruits, try different things, and you can fake people that way. Okay, so it's a real cool concept of focal points and using two mirrors and then forming, putting an object here and then forming a real image at the top. Okay, thank you very much.